This is a pre-built version of the application. So if we go ahead and run it, and this is training data that we will be using, and this is the x1 column, and this is the x2 column, and this is the label, and +1 is represented in green, so those data items, and -1 is represented in red. And after 3 rounds, we end up with this overall classifier that correctly classifies all the training data, and it is made up of the sum of the weighted weak classifiers, so H1, H2 and H3, and they're weighted with alpha 1, alpha 2 and alpha 3, and we take the sign of that summation, and this is H1, and since flag is true, data to this side is classified as -1, and to this side as +1. So this data item was misclassified, and this is H2, and since flag is false, data to this side is classified as +1, and to this side as -1. And this data item was misclassified, and this is H3, and data to this side is classified as -1, and to this side as +1, and those two data items were misclassified. And next, let's try to classify a couple of data points. So maybe one here, 2 and 2, and another one here, 4 and 1. And this was classified as -1, and this was classified as +1. And I will be going over what formulas were used here while writing and testing the code. I will start by creating a new Python file, and this will be the training data that we will be using. So this is the x1 column, and this is the x2 column, and this is the label, either +1 or -1. And the X array will contain the features, and the Y array the labels. And this class will have the AdaBoost logic, and let's go ahead and import NumPy, since we will need to use it here. So we will pass X array and Y array to this constructor as matrices, and the overall classifier will be made up of tree trunk classifiers, which will be represented by this class. And we will have a display helper class, and each will be an array of tree trunk classifiers. Now, before going any further with the code, let's do a quick introduction. So, boosting combines several weighted and specialized weak classifiers into a strong one. And by specialized, we mean that each one of those weak classifiers is good at different parts of the space. And boosting does not suffer from overfitting, and it does binary classification and produces either +1 or -1. And this is the formula for the overall classifier. So lowercase h here represents weak classifier, and alpha is the weight for each one of those weak classifiers, and we take the summation of them, and then we take the sign of that summation. And our objective is to find all the weak classifiers and their corresponding weights. Now we start with the same weight w for each data item, and n here is the number of data items, and at every round the sum of weights must add up to 1, and we calculate the error rate for each classifier. So epsilon is equal to the sum of the weights of the data items that were misclassified, and then we pick the classifier with the lowest epsilon, and we calculate alpha for that classifier using this formula, and then we recalculate the weights w according to this formula, and z here is equal to this formula, and we terminate successfully if the overall classifier classifies all data items correctly. And in each tree trunk classifier we need to keep track of the ID, and the feature. So for example, for this classifier for H1, the feature is X1. So in round 1 we have H1 and the feature is X1, and this is the threshold. It's here. So we are also keeping track of the threshold and the less than flag. So since less than flag is true here, then data items to this side of the decision boundary are classified as -1, and to this side as +1. If the less than flag was false, then we would have the reverse. And we also keep track of the error rate epsilon. So this is how we calculate epsilon. And for H1, epsilon is 0.2, and this is y hat for this classifier. So only this data items 2.9 and 2.8 was misclassified. So for y it's -1, for y hat of h of x it's +1. And we keep track of alpha. So here this is the number that we found for alpha, and we calculate it according to this formula. And x wrong, so since we only have this data item that was misclassified, so only this one has x wrong to be 1. And w here is all 0.2, since we start with the same weight W for each data item, so it's 1 over the number of data items, and we have 5 data items. And we keep track of the sum of alpha y hat. So alpha here is this number, and y hat of lowercase h of x is 1, so we end up with this number. Since we're in round 1, so the initial summation is 0. And we initially start with y hat of h of x is 0, and then we end up with y hat of h of x is all 1s. So only this one was misclassified. And we keep track of w previous and y hat previous. And z we calculated according to this formula. And this method will update the feature, the threshold, and the less than flag, and the error rate, and y hat, and x rank. And we will have get and set methods for all of those. And this method will end up calling the toString method, and in the toString method we will print out those 3 tables for each week classifier. And we will need the text table to do that. And going to the AdaBoost class, we will have this train method that implements this logic that is executed at every round, and this will keep track of all the weak classifiers. And the train method is invoked whenever we instantiate a new AdaBoost class. And here we will first calculate W. So we start with the same weight for each data item. It's 1 over the number of data items. And we will have 2 matrices for the sum of alpha y hat and for y hat previous of the overall classifier. And while true, we will implement this logic. So we need to find the classifier with the lowest epsilon, and this method will do that. And return that classifier, and we will call it from here. And we will set the previous before proceeding. So we set W previous, and we set y hat of the overall classifier previous. and we need a method that calculates the alpha for the classifier that we picked here according to this formula. And we will call that method from here and add this best weak classifier to the array of weak classifiers. And we need a method that recalculates W according to this formula with this Z. And we will call this method from here. And this is the rest of the logic here. So we terminate successfully if the overall classifier classifies all data correctly. And we need a method that calculates the error rate for each classifier and picks the one with the lowest epsilon. So this one does that. It is calculating epsilon here and checking if epsilon is smaller than h.get epsilon. And this find best h calls on this method. So let's go up here and define the number of steps. Let's have it 10 for now. And we still need to add those two methods here. This one to calculate y hat and this one to find the misclassified percentage. And what remains are two methods, a get one for h and the classify method that does the classification. And next let's go up here and import those three and add those here, and we will be using all that in the display helper class. So this method picks a random color for the for each weak classifier, and this method does plotting, uses matplotlib to do that, and this method prints the resulting overall classifier. And this function handles command line entry and calls on the classify method of the AdaBoost class, passing in what the user entered as a matrix. And finally this gives us a display helper instance that we will use for plotting and printing the result table. And finally we'll call the handle command line method after the user closes the display window. And let's go up here and change the indentation here. So now we have the correct indentation. And finally, let's go ahead and test run the application. So we went for 3 rounds. And ended up with this overall classifier. And we have alpha 1 is this number, and alpha 2 is this number, and alpha 3 is this number. And this data item was misclassified by H1, and this one was misclassified by H2, and those two were misclassified by H3. And let's try to classify a couple of new points, maybe 3 and 3, and 4 and 4. So this one was classified as -1, and this one as +1.